Okay, so we're going to start out with 2.5 and 2.6 today, and it's mainly dealing with the least squares regression line and understanding how that's developed and what it really tells us. So to start out here, we're going to look at Barbie. Alright, so again, I wish we could have done this activity, but we didn't get a chance to. So, if we attach rubber bands to Barbie's feet and drop her, again, the amount of rubber bands we added, then we see how the lowest point her head reaches, okay? With this, the first one wants us to calculate this, or make a scatter plot and then calculate the squares regression line. So, first off, let's make a scatter plot. Let's make this look like we need it to look. So, in the calculator, I already put these values in there for the bands. I went to spreadsheet in my home screen, and then for the head, this is the lowest point of the head, I put those values there. I left 5 blank because if you look, right here, there is nothing there for that one, okay? So we got nothing there for number 5. So, on the calculator, let's go ahead and make this work. Now, to make a scatter plot, I'm going to hit, since I've labeled my columns there, bands and head. So, Control, Doc for a new page. I want to make data and statistics. On the x-axis down here, I want to put the bands, because that was our explanatory. Response was her head, how low her head got, right? However many bands we put explained how low her head got. So that should give us a dot plot right there. Now, it really wanted us to do next is calculate the squares regression line and write the equation. So to get the equation, calculator should help us out too with this. So you can simply hit menu, 4 for statistics, stat calculations, and then you want to do a linear regression A plus BX. Then we're going to label which list we use. For X value, we wanted the bands, so how many, that's the explanatory variable. The response was the head, and then OK. Now, it gives us right here as far as saying A plus BX, so the equation. So A is 25.33, and our B value is 7.46. So for this will be written as your Y hat is 25.33 plus 7.46, correct? Yes, 7.46x, okay? In other words, they're saying the low point is 25.33 plus 7.46 times our bands, rubber bands, okay? Those are the same thing, it's almost the same thing. I just want to show you that is what that means. So our response variable is a low point. What's explaining that is our rubber bands, okay? So now it wants us to use the regression line to predict the lowest point that the head reaches for 5 rubber bands. Well, for that, all we can really do is, looking at our scatter plot here, I'll make this real quick. All right, so put that in here. Now it's wanting us to find the lowest point the head reaches. So to determine number 2, we need to go ahead and easily calculate this from the equation we have here. We know how many rubber bands they want, and the least squares regression lines to be able to tell us where the y value should sit on that line. So that imaginary line that this equation draws in between all those dots is what we're trying to find for the value of 5 rubber bands. So let's do that. So we have y hat equals 25.33 plus 7.46 times number of bands we have was 5. And what does that give us? Well, let's look at the calculator. Let's go home real quick. I'll say 2. All right. And so what was it? 25.33, I believe, right? Yep. 25.33, 746. 25.33 plus 7. What was it? 7.46. 0.46 times 5. That should give us 62.63. 62.63 centimeters. That's what we got according to the least squares regression line. So now group 3 says that they have 64 centimeters for 5 rubber bands. Well, we can definitely see that our prediction was too low, right? Because we said 62.63, so ours was too low. And how far off? Well, 64 minus 62.63. So 64 minus our answer, 1.37. So 1.37 centimeters. Okay. Now, the next problem we're looking at here, for number 4, is predict the lowest points of R's head would reach for 20 rubber bands. Would you trust this prediction more or less than the prediction you made in number 2? So number 2 is talking about when we predicted that it would be 62.63, but now it's saying 20 rubber bands. So let's see how this works out. Well, if we're going to do our equation, 25.33, again this is y hat, equals plus 7.46 times 20. Let's see. What does that give us? So I'll go up here, enter, and then I'm going to say 20 for our bands. So 174.53. So 174.53 centimeters. So that's pretty dang far, right? So is that trustworthy or not? Well, I'm going to say it is less trustworthy, right? So it's less. Oh my goodness, I can bring my S's. So less trustworthy. Because 20 rubber bands is so far away from the data points, right? We only went up to 7 rubber bands. So 20 rubber bands is too far away from the data points. Too far away from the data points. Okay? So with this Y-intercept, let's see what we got here. Y-intercept, the equation of the regression line, what does it mean? So our y-intercept, hopefully you guys understand that our y-intercept is simply 25.33. So our y-intercept is 25.33. As far as just like what you would see in a regular equation back in algebra, y equals mx plus b, your y-intercept was that guy, right? And your slope was the m. Well, this is just written differently. Our y-hat is written as y as far as b plus mx. So in other words, our y-intercept is 25.33. And what does that mean? Well, that means that with zero rubber bands, the farthest our head would go down is 25.33 centimeters. And what is the slope of the equation of the regression line, and what does it mean? Well, our slope
You having Josh over there?
is 7.46.
Yeah.
So our slope, 7.46. That's our m value, right? So with our slope being 7.46, that means for every rubber band added to her feet, she would go down 7.46 centimeters. So again, that's saying that we got, for every rubber band added, every rubber, how much say RB, rubber band added, Barbie's head will be 7.46 centimeters lower. Okay? Alright, so that takes care of 2.5. So now we're going to 2.6, dealing with the same setup with dealing with our regression lines, least squares regression line, but we're going to do some different numbers here, dealing with GPA and your ACT score. So again, they want us to make a scatter plot and then calculate least squares regression line and write the equation below. Okay, so to do this, we're going to do this in Google Sheets. So as you can see here, I've already put the data here at GPA and the ACT. When you do that on Google Sheets, to calculate your least squares regression line, you simply highlight these, okay? Then over here, you'll see a little button that says Insert Chart. Click on that, and look at that, you've got a scatter plot right there. Now, if you're just wanting to draw your actual line there, you see up here at the top where it says Chart Editor, where it says Customize. And then you want to go down to, scroll down a little bit. Oh, I'm sorry, you're going to scroll down to Series. Click on Series. And then you might want to scroll down a little bit if my mouse won't work for me. There we go. And then you want to add Trendline under Series. Now on your options under Trendline, it says Label, and you want to say Use Equation. And there's the equation for a least squares regression line. And I will then close this, yeah, so we can see this a little bit better. Maybe we can zoom in a little bit. There we go, a little bit better now we can see it. Okay, I got it. So there is our least squares regression line equation. So you can do this just like you can on the calculator, but even easier through Google Sheets, okay? So we know it's 11.5 times x minus 15.1. So we got 11.5 times x minus 15.1. Okay. Oh my goodness, that is horrible. I'm scribbling. Come on, work for me, pen. There we go. Y hat equal 11.5x minus 15.1. Now, to write that similar to how we wrote it earlier, right? It's where if we're going to actually be consistent, which you need to be, that's going to be y hat equals negative 15.1 plus 11.5x, okay? In other words, the ACT score is dependent upon your GPA. Okay. Now, what is the y-intercept of the equation of the least squares regression line? What does it mean? Well, of course, we got our y-intercept is negative 15.1 is your y-intercept. So if you get a 0 GPA, then you will have your ACT score will be at negative 15.1. Is that possible? No, but it could happen. All right, so then what is the slope of the equation for the regression line? What does it mean? Well, our slope is 11.5. And it means for every GPA point you increase, your ACT score is going to go up by 11.5. Now let's add one more student to the GPA of 3, ACT score of 28. Okay, what is the new equation? So again, it wants us to add in these values. So we can simply do that with 3.0 and 28. Oh, not that one. So now I'm going to delete this so we can get to here. So 3 and 28. So we added that to our list. We do the same thing, highlight them all. And we're going to hit the little insert chart. So we got our chart now. Customize, series, and we want to go down here and say add a trendline and look at our label as our use equation. Okay. So now our equation is 8.35 minus 3.35. So 8.35x minus 3.35. Minus 3.35 plus 8.35x. So what is the y-intercept? Well, our y-intercept now is negative 3.35. And we know that that is if we get a 0 on our GPA, we'll be at negative 3.35. And of course, that actually looks like it went up, right? Because we were aware at negative 15. So for this, it should have gone up for us. Okay. And then what is the slope of the new equation? Well, we have new slope is 8.35. And of course, what happened to that slope? We had a slope of 11.5. So our slope went down. So that's all that happened with that added data point. All right, guys. Hopefully you understand a little bit better on dealing with least squares regression line and how it predicts data points when given the spreadsheet, or I should say a list of data points. You can use the Google Sheets to work this out, or Excel, and you could also use a calculator if you have that as well. So hopefully that helped out, guys, and I'll see you next time.